Okay, now you pretty much got it. Now you've gone to, subscripted numbers and stuff like that, and you pretty much got them right. I'm going to continue with words, and then we'll translate all the words at once, okay? So mass is density times area, and that's going to be times distance from the axis squared, right? Now, where is this thing? Well, this part of the picture is still here. Let's just say that this is our ij increment, okay? With sample point xi star, yij star. Now you just said what it was, and you were right. But just to illustrate it, so we have reference in case anybody forgets, then what's this distance from the axis? Axis implicitly at the origin. I wasn't real specific about this. Well, you've got a triangle with a side xi star and a side yij star, right? So, I have a good place to draw this thing. Well, let's just draw it a little bigger. And I'll call this Rij star. The radius of the distance of the ijth sample point from the origin, right? And clearly that's the square root of xi star squared plus yij star squared. Okay? And that's, you said it, so that's totally right. But just to be sure that we have some kind of record of what was right, I wanted to draw that out because it's kind of important to be able to do that, okay? Sometimes it's not as straightforward, right? Often it is. Now, what's the density? Well, density is just the same as it was before.
Rho.
Yeah, we'll call it rho. And in the specific problem that we did, rho would still be m over pi r squared. That doesn't change with your coordinate system. Your density, your mass per unit area is what it is. Okay? But now I'm going to call it rho because I want to leave the possibility for a variable rho. Okay? And your area is just delta xi delta yij, and it's supposed to be the square of this distance, right? Right, the square.
Isn't it just delta y sub j?
Huh?
Isn't it delta y sub j?
No. I mean, you got to know which which sample x sample point you're using, right? You got to have an I in there because this refers to the density of one single increment, okay? Or the area of one single increment. And that increment has two subscripts. If it's just yj, well, you'd have yj's in this interval that aren't included in this interval. Everything on your y has to be referenced to which, to your x coordinate, okay? In this case, the sample point within your interval of your x partition, okay? So now, a moment of inertia. I came in and fixed it. heat. Notice it's 10 degrees warmer in here today. So I don't have a place to hang that thing, I have to carry those things. Okay, so your moment of inertia is the sum of your delta I, your delta I sub ij's, right? Which then is a double sum from I equals 1 to n, from j equals 1 to m sub I. Just for every x value in this partition,
Public speaking, by the way.
you'll have a different set of y values in that partition. So you got to have the I.
Won't your index go from 0 to n?
I'm sorry?
Won't your indexes start at 0? That's how you wrote it down.
Smile at the end of infinity, would it?
Yes, they do.
I'll laugh. Except Drow. Drow,
Okay.
that was sad. Everybody else.
And then it's just this expression.
You too.
Now we're going to write this as rho times xi star plus yij star both squared. And that's a delta xi, delta yij. I don't want to smudge that out and rewrite it, but you should understand. Same thing we've got here, okay? And this approaches as all your delta x's and delta y's approach 0. The integral of rho times x squared plus y squared d something, okay? And let's be careful about how we do this, because the order of these things is now going to matter, simply because the y partition depends on which part of the x partition you're looking at, right? So since y depends on x, well, you know from doing integrals, if you've done a few of the integrals that we've assigned, you want your x, which goes from negative r to r, to be your outside integral, because your y depends on x. And you couldn't have it the other way. When you integrate with respect to y, you're going to plug this in for the y's, and you're going to get x's. If that was your outside integral, you wouldn't have any way of integrating over x. You would have integrated over x when you shouldn't have. Okay? So there's your integral. Now, this integral and the integral we wrote for polar coordinates are going to come out the same. Okay?